Maybe the greatest thing, or one of the greatest things that mankind has ever done in terms of achievement, is to go from the Earth to the Moon and back. It was not an easy journey, and David Hartman has a panel of astronauts here. They're going to take us through it. Let's welcome the Mercury, Gemini, and Apollo astronauts.
Lesson learned. Turn on your mic. In alphabetical order, here they are. Buzz Aldrin, Air Force fighter pilot, PhD from MIT in astronautics, astronaut in '63, drove the lunar module, was the pilot for Apollo 11, and of course walked on the moon in 1969 with Neil Armstrong. Vance Brand, Marine fighter pilot, test pilot, astronaut in '66. He flew Apollo Soyuz and then 3 Shuttle missions. Scott Carpenter, naval aviator, test pilot, was one of the original 7 in 1959, flew 2 Mercury orbital flights, and he has become, in his distinguished career, an expert on the oceans and utilizing the oceans and the water. Mike Collins, Air Force Major General, retired, test pilot, Gemini 10, Apollo 11, spacewalk in Gemini 10, became Assistant Secretary of State, and was the first director of the Smithsonian Air and Space Museum. Gene Cernan, naval aviator, captain, retired, fleet pilot, astronaut, flew Gemini 9, was the second American after Ed White to walk in space, flew Apollo 10 to within 50,000 feet of the moon, and then, of course, flew Apollo 17 and was the last man to walk on the moon. Jim Lovell, naval aviator, test pilot, program manager on the F-4, flew Gemini 7 and performed the first rendezvous in space. Flew Gemini 12 with Buzz Aldrin. That was the last Gemini flight. He flew Apollo 8 with Frank Borman and Bill Anders, and then, of course, flew Apollo 13. And in Apollo 8, they were the first Americans to leave the Earth's gravity. And finally, the indomitable, the indestructible Wally Schirra, naval aviator, fleet and test pilot, one of the original 7 astronauts, and the only astronaut to fly Mercury and Gemini and the Apollo programs. Those are our guys here today. Looking back just briefly, in 1957, the Russians put up Sputnik, the first satellite, and then in April of 1961, a Russian, Yuri Gagarin, orbited the Earth. That kicked the United States into a new mode. President Kennedy went before Congress the following month in May of '61 and said we would put a man on the moon and return him safely before the end of the decade. Looking back, it seems remarkable that in 8 years, there were 6 Mercury missions, 10 Gemini missions, 11 Apollo missions, and we did, within 8 years, bring Neil and Buzz back from the moon, having accomplished what the president said we would. So let's get started. Scott, you were the first of this gang to go up. What were the most significant things going through your mind as you sat atop the rocket Mercury before you went off that first time?
Let me just add one thing to color this whole conversation. You will hear now about ancient times in terms of spaceflight. The late 50s, early 60s, there was a writer named von Däniken about at that time. He wrote about ancient astronauts. None of us believed in them. I never did. Now I find I am one.
Wait, Scott, having said that, you and Wally, there has been so much written about the selection process of the original 7 and how challenging that was. Both Wally and Scott, what was that process like, if you'll describe it for us?
Depends on who you ask. I found it fascinating. It was an outlet for intense competition, Mr. Schirra. They examined every body opening possible. They even made some other ones to examine. It was a fascinating thing because it gave us a new appreciation for what a marvelous machine the human body is.
Wally, how did you like that process?
I go back a little bit before those exams. We were at a meeting in Washington, D.C., and on the stage were 2 engineers and a shrink, a psychologist, telling us how neat it would be to get in a capsule on top of a rocket. I said, I want out of here. They said, don't worry, we're going to send monkeys and chimpanzees first. I knew I wanted out of there. I thought they were looking for that guy that got shot out of a cannon into a net at the circus.
Scott, that first sitting on top of the rocket, what were as you led up to that first flight, what were your greatest concerns, thoughts, apprehensions, whatever?
People wonder what you think, but the answer to that question is really very disappointing. It's just another day at the office. You've done it so many, many times before that you're just relieved that this time it is real and not for simulation.
What was that first flight like?
Supreme experience. The view is unforgettable, particularly when you realize in the back of your mind that so few have had it. The fragility and the beauty of the planet beneath you is transcending. It's just a remarkable, never forgettable experience.
Wally, you went on the next flight. What was it like for you?
I was thinking on the launch pad, and Walter Cronkite makes a big scene out of this. Just think, Wally Schirra was lying there on his back, contemplating the fact that these millions of parts were assembled by the lowest bidder. That wasn't the case at all. The real story is that each one of us were anxious to get a flight, and we said, thank God at liftoff, and that someone else couldn't steal the flight from us. That was the significant part. I'd like to make another remark, though, about, you mentioned Sputnik. I was at Patuxent writing up a flight test report on the F-4D when the booster of Sputnik went over. Mach 1, Mach 25, that's a pretty good deal. So we started getting into this competition with the Soviets. It was rather amazing to think of it, because after Sputnik, we sort of got interested. We tried Explorer and Vanguard, finally got something into orbit. Shortly after that, the Russians launched a vehicle with a dog in it by the name of Laika. We call that Mutnik. We were getting kind of worried, and we started flying those monkeys and chimpanzees. As time went on, we began to realize we were in real trouble. They orbited Earth with Yuri Gagarin, as you mentioned. We were getting thousands of telegrams from the ASPCA, the Society for Prevention of Cruelty to Animals. So we launched Alan Shepard.
Scott.
Wally.
Wait, what, Gene? What?
Followed by Wally Schirra.
6. I know, I didn't look at you.
Let me add one thing in a philosophical note. Leave the comedy to our favorite stand-up comic. It's an important feature of the early space program, I think, to make note of this competition with the Soviet Union, which drove us on both sides of the Iron Curtain to do better work. I have thought for some time that this friendly, constructive competition with the Soviets kept us, at least helped keep us out of World War III. We're both competitive people, the Soviets and us. We had this constructive way to compete, and I think it was a very good thing for the international relations that came from that. We all needed, as a part of our national security, preeminence in space. At that time, preeminence was to fly, and then it became to go to the moon. I prefer to think that we didn't win the space race. The Soviets lost the space race, and it's important for us all to realize, I think, that the reason for that, they're losing, is that communist countries and communist citizens cannot compete successfully with free nations and free men. You believe that?
Wally.
I think we're seeing here a collection of test pilots and engineers, and I think the major thing that happened from Mercury all the way through Apollo, even through Apollo-Soyuz, was that we could communicate and became buddies with the engineers. We were very close to them. And I can name every one of those engineers that made the flight work. And I still hear from the two engineers, John Healy and Fred Peters, on the anniversary of my Apollo flight, saying thank you for working with us. Right. That kind of bonding is what made the space program go.
Jim Lovell, Gemini 7, you're now into the next stage with two-man flights. That first rendezvous, how significant was that?
I was very happy to be on board Gemini 7. Of course, that was, first of all, a 2-week mission with Frank Borman, and 2 weeks any place with Frank Borman was a trial. But it's, of course, as I think you know, Wally knows quite well, and most of you do too, that 6 was supposed to go before 7, and then their Gina didn't make it, so we fired Gemini 7 first, a 2-week mission, and then Wally and Tom Stafford were to follow us. They tried the first attempt, and it didn't get off the ground, and so we were up there for about 12 days already, and the engineers miraculously turned that vehicle around, the rocket. They found out the cause and sent Wally and Tom Stafford up, and we had that very first rendezvous. I can still recall them coming up from below at nighttime, their thrusters firing as we came together. And we stayed together for about, what was it, about 6 hours, 7 hours? And within 2 feet of each other. We didn't have a docking probe at all, so we couldn't dock. And then during a very appropriate time, during the daylight, with 2 Naval Academy guys in Gemini 6 and myself and the West Pointer next to me, Tom Stafford put up a little poster that said, "Beat Army." I took the picture, and it's the highest Beat Army rally we've ever known.
Mike Collins, Gemini 10, what happened on Gemini 10 and spacewalks and so forth?
Well, yeah, spacewalks are a little bit different. That was something Gene tried before I did, Ed White before Gene, and so on. To this group, you know, talking about the differences or the similarities between airplanes and spacecraft, I think I'd rather talk about the differences. You know, in an airplane, you try as hard as you can to keep the pointy end going forward, and in the spacecraft, it doesn't really matter. You know, you don't have any rudder pedals. That's not all that important, but you have a 3-axis hand controller, and if you turn your hand, you can go sideways, which is kind of cool. That's especially cool. I thought on Gemini that was just a very unusual feeling to be. There you are going sideways around the world. The door's open. You're standing up on the ejection seat. You hope the pins are in. And so that's that business of yawing is the big difference. Another thing I thought was kind of interesting going from airplanes to space was communications. I mean, you don't really think about it in an airplane. You talk or you don't talk. They talk to you mostly. In the distance between the Earth and the Moon, you have to communicate via a high-gain antenna, which is a dish antenna, and it's located, I can only put it in delicately, it's located at the right cheek of your ass. So if you really want to talk to somebody badly, you have to sort of turn around and moon them. And this is sometimes not altogether convenient to get your fuselage between the antenna and the ground, but that's something you have to something additional you have to think about. Another thing is if you fly along in an airplane, you don't much care which way the sun is coming from, but between the Earth and the Moon, you have to worry about that as well. If you just sit there stabilized, the sun boils fluids on one side of your craft, and that's bad, and then they freeze on the other side, which is just as bad. So going to the Moon, you have to turn sideways to the sun. You have to rotate like a chicken on a barbecue spit. And that's kind of a strange way to travel when you think about it. You can't really see the Earth getting smaller. You can't really see the Moon getting larger until suddenly you're in the shadow of the Moon. You stop this barbecue motion, and there that thing is. I mean, kids today say, awesome. That is really awesome. You know, this huge, gigantic thing fills your whole windscreen. It's very three-dimensional. It bulges out at you. It's you're in the shadow, which is kind of an eerie bluish color, the sunlight bouncing off the Earth back to the Moon, and then around the rim you can see the sunlight cascading and getting very, very bright, almost any color you want. Well, those are just some of the differences.
Gene, let's go back to Gemini 9 and what Mike just mentioned, that Ed White walked first, EVA'd first, you were second.
Let me just pick up real quick on something Mike said. Some of my colleagues have said flying in space is a natural extension of flying airplanes. It was not for me. You're truly operating in a 6 degree of freedom environment, and the venue, 250,000 miles away from home, is a lot different than a venue at 40,000 feet. Gemini 9, we were to build on a rendezvous of Gemini 6 and 7. We were to build on the experience of getting out of spacecraft, EVA, spacewalking, of Gemini 4. Ed White was out about 20 minutes. But we lost something in between. Gemini 8 was supposed to pick up on those things. They were rendezvous and docking, which they did, Neil and Dave Scott. And they docked with the Regina, so they did a rendezvous, but there was a lot of other things they were supposed to do, including a very extensive EVA that Dave was going to conduct, which might have taught us a lot prior to Gemini 9. Of course, they had to abort their mission, came in early, so there we were on Gemini 9 with the requirements of conducting several different rendezvous, daytime, nighttime, without the slide rule, with a pencil, all kinds of different things. We did all that. We lost our Regina. The first time we tried to launch, our Regina went up on an Atlas and came down. The second time we tried to launch, our computer sort of went haywire, and this is my first time around. I'd never been on a rocket before. You could hear that big Atlas go up, the one Wally and Scott were on, and and you could almost hear it blow up, and we're next. See, we're next in line, and I wasn't sure that this was the real thing to do, but I would have gone on that flight had they strapped me to the outside. But the bottom line was we had to jump from the 6, 7 experience of rendezvous and the Gemini 4 experience of 20 minutes of EVA, and trained to fly an Air Force experiment, an astronaut maneuvering unit, literally on the end of about a 125-foot tether out around the sky, like you've seen them do in a shuttle. It required us to get out behind the spacecraft in a hard suit. The Gemini suit I compare to like plaster of Paris. Once it decides that's where it's going to put you when you pressurize it, that's where you are. Move your arms and legs was very, very difficult. We had to go out behind I had to go out behind the Gemini spacecraft in the adapter section and basically assemble this AMU. Just prior to that, part of that EVA protocol was for me to evaluate umbilical dynamics. Now, Ed White went out and he had a little gun to stabilize his body, and you've seen these massive, beautiful pictures, and they're tremendous. Ed White was smaller than I am. He had a little trouble getting back in the spacecraft, but we didn't pay much attention to those problems either. So I went out and evaluated umbilical dynamics, and the first thing I knew was this wasn't going to work because, every time you pull, you could never pull on the umbilical through your center of gravity. So you go tumbling through space. the most helpless feeling a human being can have, particularly if you're the kind of person who likes to maintain control of what's going on. And I finally did that in that first daylight pass, went out behind the spacecraft, worked my way out behind the spacecraft, and I had to turn valves, I had to push arms of this maneuvering unit that I was going to back into like a seat and twist them and turn them. I had a couple little pen lights back there, one of which didn't work, and I had a couple little handlebars and a footrest. And you think we would have been a little bit smarter than that, because there's a footrest doesn't quite hack it in zero gravity. You got to have some place to anchor your body. And I would put one foot under that footrest and another foot on top just to try and hold myself there. I'd wrap around the handlebar and try and twist a valve. The valve would twist me back. I'd try and telescope an arm on the AMU to get it assembled and extended, and I'd just go floating out there somewhere in space and had to work my way back to the back end. It got pretty tiring, to the point that I overpowered my environmental control system in my cooling system and pressurization system in the spacesuit, and I was literally all fogged up. It's like getting out in your car in a cold winter morning and the windshield just completely fogs up, and I was on the inside. I remember going over Australia at night one time, and I could rub a little hole with my nose and I could see the lights down there somewhere. Wonder why in the hell am I up here at night? But it was frustrating for me because I couldn't get the job done that I was sent to do. And the doctors were getting pretty concerned. My heart rate was running, I guess, 160, 170. I eventually was able to effectively assemble that backpack. I literally took my umbilical, which supplied me with oxygen from the spacecraft. I disconnected it. I had by that time connected the oxygen from and a radio cables from this backpack, because I was going to be an independent satellite on a tether, yes, but independent. Disconnected it, so I was breathing the backpack oxygen, was talking through the radio, not very clearly. Tom Stafford couldn't hear or understand me very well. The ground was getting a little concerned, and I remember sitting in that thing, and all Tom had to do was flip the switch, and I was gone. I was out there. And one of the unique things about the AMU, unlike the cold gas nitrogen systems they use in these backpacks they fly around in Shuttle and on the station, is we had hydrogen peroxide. We had real rockets. And I had quads of rockets up here and down here. And I remember when we first were designing this unit, they had one of those hydrogen peroxide rockets coming out between your legs. We changed that design pretty quickly. But on top of that, and I should have got the message. On top of that, I had to wear steel pants, Quomel woven steel pants, to keep this thing from burning a hole in my suit if it chose to do so. There were a lot of cues we didn't pick up, including the cues that we learned in 4th and 5th grade about F equals ma, and for every action there was an equal and opposite reaction. And boy, in zero gravity, it comes home so loud and clear. Bottom line, I was ready to go. We couldn't talk to each other. I was pretty tired. So we decided to abort that part of the mission. And I truly was extremely disappointed, because I know had we had the time, we could have flown that part of the mission successfully. And I was disappointed because, as I said, I let these guys down. I didn't do what I was sent up there to do. In retrospect, looking back, had Tom cut me loose and I'd flown around out there, our plan to get out of this thing was to hold on to the docking bar of the front of the Gemini, and with one hand unbuckle and unstrap and put the new umbilicals in, which required a tremendous amount of force, which literally required the old F equal ma. You have to hold on one end to plug in. And in retrospect, I'm not sure that getting out of it would have been any easier than getting back in. Getting back in, the spacecraft itself was another job. And to shorten that, I'll just say it's like putting a champagne cork back inside a champagne bottle. It was next to impossible. The Gemini spacecraft was extremely small. As I say, a pressurized suit, the steel pants. I'm a little bit bigger than Ed White was. We could do it on a zero-G airplane every time, but we had 20 seconds, and we got part way in, we'd run another parabola, and we'd get in with the next 20 seconds. We never allowed in our training zero gravity to propagate, so we never fully were aware of the problems that we might encounter with that propagation. Finally had to get in the spacecraft, had to bend my legs, well, literally like a cork. Had to reach out, close that hatch, got it closed on an alligator clip. Tom Stafford reached over. We had a little lever chain. He reached over and pulled it across, and that hatch came down upon my head, and I was literally like a pretzel stretched out with my legs doubled up under that ejection seat Mike talked about, and ready to die. And I told Tom, get this spacecraft pressurized, and he did. And when he did, of course, my suit came down, and I was able to unbend and get my helmet and gloves off. And at that point, Tom broke the cardinal rule. You know, water can be the worst possible problem you can have in a spacecraft. Tom looked over at me, and he said, "You look like a boiled turnip." And he took that water gun, and he put it right in my face and just blew it all over me. So we had zero-G water all over that spacecraft. One little side note of that, just before we lifted off, Deke Slayton called Tom. We were in a trailer where we got suited up in a Gemini program, and Deke called Tom over to his side, wanted to talk to him. And this was very unusual, because when Deke talks to you before you fly, he talks to both of you, the weather, the recovery, but he took Tom over to his side and came back, and I said, what did Deke have to say? No problem, everything's fine, you know. And it wasn't until, I suspected this, but it wasn't until many months after the flight that Tom finally told me that, well, you know, he told me, if you have some trouble out there, I'm just going to have to cut you loose. But I told Deke, I'm the commander of this flight, and I'll do what I want to do, and I'm not going to, Gino, I would never cut you loose. Now, in my mind, I had an idea. In my mind, I knew what the risks were, but let me tell you, if it's you out there, you're not going to not get in. I mean, I was coming home. But Tom swore up and down that he would never allow that to happen. And it wasn't too many years later on the History Channel, I turned it on and watched Tom Stafford. He said, well, you know, if Gene got caught out there, you know, he's going to burn up during reentry anyway, and I can't come in with the hatch open. I wouldn't have had any choice. Anyway, I'd like to look back and think that we eventually learned something, and that Mike and Dick Gordon and Buzz picked up from the mistakes I made and allowed us to do the things on the moon that we did because of some of the mistakes and some of the knowledge or some of the cues that we didn't pay attention to on Gemini 9. Maybe this is self-serving, but I like to think that maybe Gemini 9, like Apollo 13, was not a failure, was a success.
Buzz, you and Jim flew the last Gemini flight. What were the final tasks, and to what extent was it a wise end to the program to lead into Apollo?
Well, I got to say first that I'm probably one of the most fortunate ones in this whole room. I didn't start out to be a test pilot. I got into this business by being an egghead from MIT. And I got fascinated with orbital mechanics and applied for the second group of astronauts. And they didn't want somebody who hadn't been in the test pilot business. But I had some interesting things in my background. And so I did get in the third group. And Jim and I were scheduled to fly to be on the backup crew of Gemini 10. So the normal rotation is you skip the next two flights and then you get to fly on the third one, which is Gemini 13, but there wasn't any. And here I'd gotten involved in rendezvous at MIT and was hoping to be involved in an early rendezvous flight. And here my future was going to be backing up Gemini 10 and not even flying in the program. Well, a lot of things change. And we lost a pair of guys in St. Louis, Elliott C. and Charlie Bassett were the prime crew on Gemini 9. So they needed a backup crew, so Jim and Tom moved in, and they became the prime crew, and Shaky and I were the backup. And because of that, you know, I wish you'd told me some of those things. I might not have been that eager to have been involved in spacewalking on 12.
But the mission itself, did it get done, the things you wanted to get done?
It certainly did. We had several rendezvous. We had a tether experiment where we went gravity gradient. But as far as the spacewalking went, I think two things really happened. We matured things like foot restraints to the point where when I came along, why we had very good, very positive foot restraints. And also the opportunity to train underwater came along. And I think that's one of the major things that we got out of the program was the neutral buoyancy training that gave us the opportunity to exercise three-dimensional freedom similar to scuba diving in a neutral buoyancy tank, which was outstanding training, really, for spacewalking.
Jim, that first Apollo mission with Frank Borman and Bill Anders, how significant was that?
Well, Dave, I think the Apollo 8 mission was really a milestone in our Apollo flights. That was going to be an Earth orbital mission, by the way, just after Wally was finishing Gemini, our Apollo 7 to test out the spacecraft. We were going to take the two spacecraft, the lunar module and the command service module, on a Earth orbit, but going up about 4,000 miles and testing out both vehicles before we'd ever commit them to the moon. Two things happened, though, in the summer of '68 that changed our plans completely. Grumman, who was building the lunar module, finally came to us, and we sort of knew anyway that the lunar module was not going to be ready by the end of 1968 for a mission of that nature. And then we also had intelligence information that the Soviets at that time were planning to put a man around the moon, not to circumnavigate, but just around the moon in the late fall of 1968. And of course, as we know now, they're very serious about it. Their N1 big booster, their lunar landing booster, was a failure, essentially. But they did have the Proton, and they sent a couple Zond spacecraft up with animals to test out the concept. And one was a failure, one was a partial success. And then there was a big debate in the Soviet Union, shall we continue another flight with animals to make sure that everything's fine, or should we send the two cosmonauts on that flight? Meanwhile, in this country, a very bold move was made. A decision was made. Lunar module not ready. If Wally's flight on Apollo 7 will prove out the command service module, why don't we send the command service module to the moon, test out the navigation, the communication systems, orbit the moon, look for suitable landing sites, and get a heads up on our entire Apollo program. So that's what we did. First flight on the Saturn V. First time man had left the confines of the Earth and was captured by another body. First time three of us saw the far side of the moon, which we never see before. On the Earth, we always see the near side. And that flight, by the way, was very successful. It was also very appropriate because, I don't know, you young people remember 1968, kind of a poor year here in the United States, Vietnam War going on. A couple assassinations. There was riots in the streets. But we ended up the year on an upbeat by actually going to the moon the very first time. And consequently, when we got there, we thought, what would be appropriate to say? And before we left, of course, we were trying to think of all sorts of things. But it turned out to be a newspaper man's wife who actually came down with the idea of reading from the Old Testament, the first 10 verses of Genesis, which is really the basis of all the world's religions, even though we orbited the moon on Christmas Eve.
And who read that? Was it Bill? Who
All three of us read it. We split the first 10 verses up into 3 parts, and then Frank gave a prayer at the end of that.
So getting closer to landing, Gene, Apollo 10, you all but landed, right?
We but that time, Apollo 9 had flown the lunar module in Earth orbit, and they decided to send Apollo 10 to the moon. From what I understand, at one time, the question, should Apollo 10, if we go all the way to the moon, take the lunar module, put the crew in harm's way effectively, why don't we go all the way down? But a decision was made, and I think the right one. Said, let's take it down to 50,000. Let's take the lunar module into the, we'd had the command and service module in the lunar environment. Now let's take the lunar module, put it in lunar environment, thermally and otherwise, see how it reacts. We tested everything that was humanly possible to test on a lunar module. I like to tell Neil and Buzz we painted a white line so they wouldn't get lost on the way to the moon. And they gave them the other 50,000 feet. They had fun with that, by the way. So Apollo 10 was basically a rehearsal for Apollo 11. We flew right over their landing site. We were targeted, did everything, took pictures. Only little problem on Apollo 10 was a little bit cockpit communication between, I flew with Tom Stafford and John Young on that flight, and Tom and I were in the lunar module, and it's probably happened to everyone here at a time or two, we both had our hands on a computer switch, and I switched to the backup computer, and Tom thought it needed to be switched again, so he switched it the other way, and when we staged the vehicles at 50,000 feet, 47,000 feet, with our abort guidance computer, which we would have used on a surface had we had to use it, we wanted to test it. We staged, we broke the vehicles apart, and I saw the lunar horizon go by about 8 times in 15 seconds in different directions. That's really 6 degrees of freedom of flight. And that's when Apollo 10 became X-rated, because I said, golly gee whiz, what the heck happened?
Yeah.
And the whole world heard it, and General Mumbles said a lot worse, but no one understood Tom. We recovered from that, made the rendezvous, and came home and turned it over to Neil and Buzz.
And Mike Collins. And Mike, when you turned Buzz and Neil loose in the lander, what, besides being in the office, as Wally said, going to work every day, what do you recall about that moment?
It was nice. We've been talking about telemetry, and we were telemetered up the yin-yang. There was always someone saying, gee, the evaporator outlet temperature is 15 degrees too high, and so to get rid of those two guys, to get on the backside of the moon where no one could talk to me, and I had some peace and quiet for a little while, was very, very pleasant.
Buzz, how did the landing go?
Well, Mike is the talkative one. Neil and I don't say too much. I don't know what he's talking about. I guess there's some unusual things that I might want to note to this crowd. We had not tricycle landing gear, not nose wheel landing. We had 4 landing gear, but there was one of them in the front, and on each of the 4 landing gear, we had about a 6-foot probe. And the probe was going to touch the ground first, send a signal up to the cockpit, turn a light on, and early in the planning, it was also going to shut the engine off. Now, these test pilots didn't think that was too good an idea, so we disabled that automatic shutdown, but we did decide that on the nose landing gear, the one in the front, that when we walked down, we didn't want to stumble over one of those probes that was bent, so we had them take the probe off the front, and I think they did that on the rest of the missions. Now, on the actual descent, there's one thing that I think a lot of people here would appreciate, and that is on our particular mission, we had a different, a more primitive autopilot than they did on the later landing missions. So when we took over, or Neil took over at 500 feet, we had a 3-axis hand controller, and it was rate, command, attitude, hold. So that if you commanded a rate in pitch or roll, you were going to get a rate, but if you let go, then it held you in attitude. Well, but you got the engine burning, and if you're a little bit off exactly vertical, you're going to start moving in translation sideways or fore and aft, you're unstable. So it made the actual landing a good bit more difficult than the later flights, where the computer knew that you were translating over the ground, and it could be fed in through the computer to null out that motion, so that if you, later missions, you let the stick go, it wasn't attitude hold, it was translation will be zeroed. So it made it much more easy. The guys on the later missions don't like me to say this, but since Neil isn't here. And then there was a toggle switch that controlled your rate of descent. And you hit that toggle switch once, and you would change your rate of descent by about 1 foot per second. The landing itself obviously was very challenging because the computer was taking us to a place where Neil didn't care for particularly. There were some rocks and craters. I was giving him all the information I could from the primary guidance of 3 registers, reading off the altitude rate, and velocity over the ground. So I wasn't looking out very much to see what he was trying to dodge. But as we got to the point where the 60-second light came on, we were still 100 feet or more above the ground. You know, I had a lot of confidence in Neil, but I sure would like him to get a little closer to the ground. We got a call out from Charlie Duke, 30 seconds. We were still about 10 feet above the ground, but I felt we maybe had it made about that time. I could see the shadow of the landing gear in front of us and see the dust picking up, and we touched down and saw the contact light, and then I called out engine stop. We manually shutted it down, and we did what we set out to do, though we were pretty sweating it out there the last couple of seconds with 15 seconds of fuel left.
Wally, you flew, as we've said, Mercury and Gemini, and then Apollo. How did the Apollo mission, after listening to all this, compare with those 2 earlier experiences?
Well, I didn't have the privilege of playing with the lunar module, and I thought of the command module as one big bus. It was a pretty big vehicle, and I also recall the idea of this vehicle being so well tested. It was just unbelievable because we'd lost the crew on Apollo 1. We had almost a complete redesign of the electrical systems. The hatch was changed. We changed from a pure oxygen environment. There were quite a few things that happened. The whole team came together to get that mission ready. I think probably my greatest thrill about Apollo 7 is I actually lasted 10.8 days up there, and you couldn't eat out. But it sure showed how the team at North American came around and built a beautiful piece of equipment. I kind of think about something we were talking this morning about company test pilots and test pilots. We had no company test pilots. We all started out as test pilot astronauts and went from there all the way through. Probably the biggest surprise I had, though, listening to the shuttle guys talking, the shuttle had no previous tests other than that one flight, the very first flight that John Young and Crippen did. I'm pretty impressed with how that NASA crew pulled us all together and did what we all did.
Jim, Apollo 13, of course, the world knows the story, not only the real story, but the movies and books and all of it about A13. What caused it?
That's a good question, Dave. What really caused the accident of Apollo 13? It's a classic case that if you've gone to aviation safety school, you know that most airplane accidents are a series of incidents that overcome either the pilot or the aircraft. And this was exactly the same thing. The cause was started back in around the early 1960s when we started to build the Apollo spacecraft. At that time, and still all the way through the program, the vehicle flew at 28-volt DC power. That's what the fuel cells put out. But NASA in the early days said to all the people that managed it to make the spacecraft compatible with 65-volt DC power that was at the Cape, and we could do our experiments and our testing a lot quicker. So everybody made all the electrical and the electronic systems compatible with that higher voltage that was available at Cape Canaveral, except the person or the group that built the heater system in the oxygen tanks that heated up the oxygen to boil off a little bit, to pressurize the spacecraft, provide breathing, and feed oxygen into the fuel cells. In that heater system, there was a little thermostat that was compatible with only 28-volt DC power. All the flights from Apollo 7 through Apollo 13 started out with this little thermostat. However, as I said, there was a series of incidents that occurred. As they were building the oxygen tanks, coming down the line, one of the tanks was dropped at the factory. Not much, but dropped a little bit. Well, in all property, they refurbished the complete tank. They looked at everything that the tank could do in flight to make sure that it was okay. That tank was scheduled for Apollo 10, but since the tank was delayed in its manufacture, they erased the chalk mark and put Apollo 13 on it. The tank kept on going through the whole system. And now let me fast forward up to just before the flight, a couple weeks before the flight, with the big Saturn V sitting on the launch pad, the spacecraft on top. We went through what was known as a countdown demonstration test. Everybody was in the proper positions in the launch control area. The crew got into the spacecraft. All the spacecraft was filled up with the fuel, the oxygen, the hydrogen. We didn't fill, of course, the tanks to the big booster. Everything worked perfectly. We counted down to 0, no problems. Everybody knew what the job was. The spacecraft worked perfectly. Crew went back to the quarters. The launch people went back in to safeguard and shut down the spacecraft. One of the jobs they had to do was to detank the oxygen system out of the tanks. They had to take the oxygen out. The normal way they did it was to hook up a line of gaseous oxygen to the oxygen tanks and put gaseous oxygen into the fill line, and then the liquid would be forced out the vent line. That worked perfectly with one of the tanks, but on the second tank, the gaseous oxygen going in was going out the vent line, and the liquid stayed right where it was. Never thought about this before. It never happened before. So like all good engineers, we went back to the schematics and saw that this tank, the history of the tank, that it had been dropped, and looked at the schematics and saw that if a line or a little tube had been loosened inside the tank, this would give them the symptoms they were now seeing. So we all went back to see what we could do. We could replace the tank, delay the flight a month. And then they thought about it for a while. They said, there's a heater system in that tank. Why don't we turn on the heater system and boil the oxygen out? Because the tank worked perfectly for everything I had to do in flight. The only thing we could not do was remove the tank on a test. And so that's what they did. There were two ways of telling the temperature inside that tank. One was on the gantry itself was a temperature gauge that had been calibrated, of course, because liquid oxygen down to a -250 and up to about 80 degrees. And in the engineering compartments themselves, there was a little stylus that told when the power was on and when the power was off to that heater system. The heater system stayed on for about 6 to 8 hours, and as advertised, as everybody thought, the oxygen was boiled off completely. Everything worked perfectly. But what we didn't know was, as the oxygen went down and the little thermostat was exposed to the air, the temperature started to rise, and the thermostat would work at about 80 degrees, and when the little contacts started to open up, the high voltage welded them shut. We had no system to turn off the power going through, automatic. The little temperature gauge on the gantry went up to 80 degrees, and the thermostat was designed to open up at 80 degrees. Gauge never went up any higher than 80 degrees, because that's the highest the gauge went. The little stylus in the engineering compartment never went to 0 to show that the power dropped off. No one ever looked at it. Consequently, we know now that the temperature inside the tank got up to about 1,000 degrees Fahrenheit. completely damaged all the insulation, the stuff around the wires, and it was essentially a bomb ready to go off. A day or so before we launched, we filled it up with liquid oxygen again, took off. We actually used the heater system several times, but at about 200,000 miles out, when we turned down the heater system and the little fan to circulate the atmosphere or the oxygen, the explosion occurred. Now, the moral of the story is, if you're going to have an explosion on the way to the moon, have it 200,000 miles out. If we had that explosion when we first committed ourselves to go to the moon, we would never had enough electrical power to go all the way around the moon and come back again. If the explosion occurred once we got into lunar orbit or on our way down in the lunar module, we would never had enough fuel in the lunar module to get out of the capture of the moon and get back home again. That's the moral of the story.
Wow. Vance, before we go to Gene to talk about A-17, here you were flying Apollo-Soyuz, and as some of the others have talked about, the difference between tumbling and rolling and being the chicken on the spit and so forth. But you also flew this winged vehicle. How different was Apollo-Soyuz from flying the shuttle?
Well, that's a good question. As a pilot, why, of course, I preferred the shuttle because the shuttle gave you more control. You sort of felt like you were, after you got past the point where you were pitched, or you had an alpha of 40 degrees, and you brought the nose down, you felt like you were in an airliner, even though it was a pretty steep final approach and all that, which was more comfortable than coming in the command module with your back face to the relative wind and looking back and seeing where you'd been. Of course, looking at it today, there can be advantages to either system. One advantage to the shuttle was you had a lot more places where you could land. You know, I mean, in an emergency, you could try for a long airfield somewhere, and we had emergency airfields scattered around the world that we might have used if needed. As far as the capsule is concerned, well, you're going to land in the ocean, plus or minus about a mile from where they had you targeted to land, so you don't, of course, have as much flexibility and take ships to pick you up. One thing I liked about the shuttle, though, it seemed like wall-to-wall windows compared to the command module. Command module, you had a hatch, a porthole, a couple of other windows, and you could see it quite a bit. But in the shuttle, if something interesting was coming up, somebody in one part of the ship would say, hey, you ought to break away from what you're doing and see what's coming up. It might be Dakar, or you think maybe you could see Cairo coming up, and, or some specific thing, or a cloud formation. And everybody just felt like, almost like they were in a gondola from the view that you could have. I think there may still be a need for restricted need for capsules. Even though they don't have wings, they're easier to design. They're not quite as tough thermally, design-wise, and checkout-wise, and all. You might use one now, for example, as a crew return vehicle, and it might be the quickest, the cheapest, easiest way to go. But what I'd really like to see someday is something like a shuttle that had what they call sharp leading edges on the wings, which could stand temperatures maybe up to 4,000 degrees on the wing leading edges. With that, you could get a lot of lift, more than you can with the space shuttle. And you might have the possibility to land a lot of places around the world, and really that would cover you well for emergencies and stuff. But there are big differences, each with their own advantages.
Gene, Apollo 17, You and Jack Schmidt went up there as experienced as you were by the time you flew 17. Was there anything unusual once you got up to the moon that was different from what you anticipated or from what Buzz and Neil and the others had experienced when they were up there?
Well, you know, you always built on what you learned from the flights and from the guys before you. And yet every flight is a first flight. I don't care how many times you go to the moon. Every flight's going to be the first one. I had a chance to fly in that Saturn V, a couple different things that were different. The Saturn V a couple times. I noticed yesterday, I think it was Dick Truly or something, talked about the thrust-to-weight ratio of the shuttle. Where they're off the pad. It took us 15 seconds to clear the tower on the Saturn V. If you lose an engine in those first 15 seconds, I guess you come back down. After that, you burned on enough fuel, you're on your way. First time on Apollo 10 was during the daytime. One of the first things that was different on Apollo 17 is we launched at night. It was the first and only night launch during Apollo, and the reason we launched at night is the only way we could get to our particular landing site in the month of December. It was December 72. It's hard to believe 31 years ago. We've got young men and young women out there who were probably in diapers or at best in knee pants when we went to the moon 31 years ago. But nonetheless, it was the only way we could get there. Those of you who have landed aboard a carrier at the daytime, you will admit there's a significant difference compared to landing aboard at night. It was sort of the same thing in the Saturn V. In a case of an extreme abort condition, you didn't have the horizon. You had to use certain stars to get the spacecraft oriented, put it in the right attitude so you could get back home. There are a number of different things about launching at night, particularly in that Saturn V. Someone said from the ground it was like the world lit up from without. It was like 1,000 suns. I could literally see, looking straight up. I had the only window open in the spacecraft. Wasn't open, pardon me. It was uncovered because we had a shield over the others. But I could literally see on a cloudless night, I could literally see the light sort of reflected from the atmosphere out there. When we approached the moon, we had a landing site that was neither on the equator, nor was it from a longitude point of view near the center of the moon. It was in a northeastern corner, which required a lot of differences in our approach to the moon. And on Apollo 10, and I think probably on 11, and well, 13 might have been a little different, but certainly 8, you go into the shadow of the moon, somewhere out there, probably several thousand miles away. And on Apollo 10, we literally put the spacecraft into retrofire attitude, fired the engine at 50 feet. Our target was 50 feet. That's a pretty good shot. 3 days, 3-day lead time, 240,000 miles away, and you're supposed to miss the moon by 50 miles. I've often wondered about that, but it worked. And you fire in darkness, at least we did on 10, and then all of a sudden you come into daylight, and there's the moon right there below you, overwhelming. Apollo 17, we went, because of the location of our landing site, we went through the shadow of the moon into darkness and back out into daylight. And we were still several thousand miles away from the moon. And I mean, it just lit up our windows. And it was almost like split-S-ing into a dive bombing run from, I don't know, 4,000 or 5,000 feet at a target 50 miles above the surface of the moon. Now, Ron Evans and Jack Schmidt had never flown to the moon before. So to them, I guess this was relatively normal. To me, I mean, I was overwhelmed. I mean, here we were just blowing in at the moon at several thousand miles an hour at that target 50 miles. Fired, did a pitch maneuver, fired, slowed down, stayed in orbit 50 miles above the surface of the moon. Now, Apollo 17, as I said, built on everything other guys before us had done. We were there 3 days. We took a lunar rover to the moon. I don't expect anyone in here, but there's a lot of people out there think that we were just passengers and we just rode and someone else did the work. Mission control, quote, control our flight, landed us on the moon. Untrue, we flew. And literally, I took over the landing when we pitched over at 7,000 feet. We had some things to do that, coming in on our back, face down, checking landmarks to see whether our guidance was okay. But literally at 7,000 feet, took over and started spotting our landing site and literally flew down to the surface of the moon. And I don't know what spacecraft, Buzz, you're talking about, but we had 6 degrees of freedom, man. We put a yaw in and tilt that that vehicle over and we were moving in any direction we wanted to move. We had a switch in there that said auto. And we could literally have let the computer land a spacecraft. But I don't think there's any human being, particularly not in this room, who would have gone 240,000 miles